Hello, welcome to this lesson where we are looking at the properties of the angles of a circle. Okay, so as you can see, I'm looking at property number 1. I already dealt with the first property, so I would request that you go to you look at that property before you come to this lesson. Okay, this is the second lesson. In the first lesson, I looked at the first property, so if you can go and look at it there. Okay, so let's look at the second and third properties. What are they saying? So the second property is the angle in a semicircle is a right angle. A right angle is a 90-degree. The angle in a semicircle. In a semicircle, we have a circle, then the circle is divided into 2. We have a diameter here. This is a diameter. So we have a semicircle and a semicircle. So any angle that is formed here is what we are calling a right angle. So if we have an angle from this point, then this angle is a right angle. Also, it could be this side, and this is a right angle. It can be here, this is a right angle. It can also be here, this would be, that is what we are saying. That is what we are saying. So the angle in a semicircle is what? 90 degrees. So since we know that 3 angles in a triangle add up to 180, and 180, when you divide it by 2, it gives you what? 90. So since we already know that this angle here is 90, then we can also conclude that the remaining 2 angles, this one here and this one, when we add them, they should give us, if they are x and y, they should give us 90, because you already have 90 here. So this angle, if it's x, this one is y. When we add these 2, they must give us what? 90. Okay? They must give us 90. It's important that we get to know this concept. Once you have a diameter, if they tell you this line AB is a diameter, then check for any angle that has been formed in the semicircle. Check for any angle that has been formed in the semicircle and get to know that that angle, it's what? 90 degrees. Okay? It could be, like I already said, it can be this side. As long as, so this angle is 90. So please let's get to know this concept. This is the second property or theorem. The angle in a semicircle is 90 degrees. The angle in the semicircle is what? 90 degrees. I want you to understand that. And then, if you remember, even this same concept, it's coming from the first concept that we looked at. If you remember very well, the first concept we were saying, the angle at the center, the first one, the angle at the center here, the angle at the center of a circle is twice the angle on the circumference. Okay? Is twice the angle on the circumference. Are we together? That is the first theorem that we dealt with. We were saying the angle at the center is twice the angle on the circumference. Now, even this same concept, the same one, which is the angle in a semicircle is 90 degrees, it's actually coming from the same concept. Look at a situation where this one, we stretch these ones. They are coming here now. We have a straight line at this point. This one, they are straightened. This one comes in, this one. Okay? So we still have the angle at the center here. What is it? The angle at the center is what? 180, isn't it? The angle at the center is what? 198. You know that the angle on a straight line. So it's almost the same concept, where the angle on the circumference, the angle at the center is what? 180. On the circumference, so we can still apply that rule as well. So we are saying, the first one we are saying an angle at the center is twice the angle on the circumference. The second one we are saying the angle in a semicircle is a right angle, which is 90 degrees. Then that same concept, which is the first one that we're dealing with, brings us also to the third theorem, where we are saying angles in the same segment are the same. Angles in the same segment. So what is a segment? A segment is an area bound by a chord and an arc. If you've got this, we call this a diameter, isn't it? This part that divides, this line that divides a circle into two equal parts, it's called a diameter. So any other line that joins 2 points of the circumference apart from a diameter is what we call a chord. For instance, this one. This is called a chord. This is a chord. This, even this side. The same way, these are chords here. Chords. Okay? So when we have a chord like this, a chord, once we have a chord, if we have a circle here and we have drawn a chord here, this chord gives us two segments of a circle. This is a smaller segment or a minor segment and a bigger segment. And then we have an arc here. This is an arc. Okay? This is an arc. This part of the circumference from this side up to here. This is an arc. So this is a segment. Okay? So if you can remember from what we were saying, the first theorem, we were saying the angle at the center is twice the angle on the circumference. So if this angle here is 60, what will be this angle? This angle will be 30. And it's the same thing. Also, when you look at this one, it will still be 30. So it is bringing us back to that concept that I'm trying to explain. Even if we introduced another one here, as long as they're coming from, it will still be 30. So except that now we are not pronouncing this part, which is the center here. We say, let's get rid of this one. So this is what we are calling a segment. So here we have an arc. You've seen? Okay? We have an arc from this point. This is the arc that we are considering. This is where these two, these angles are coming from. This point. Okay? So all these, it's like now here we are assuming we have a chord. All these angles in this same segment here, they are equal. They are, as long as they are starting from the same points, this one as well as this one. We can have another one that comes from this point to come down here. If this is 30, this is 30, this is 30, this is 30. Even if you have another one there, that will still be 30. That's the same concept that we're explaining even here. That's the same. If this is 20, this is also 20, this is also 20, this is also 20. This. Look at where they're coming from. Angles in the same segment. Angles in the same segment. This one is just the opposite. Instead of going upwards, we are saying if we are using this other segment here, this angle will be equal to this other angle. We have a chord here, this line. So we have one segment this side and the other segment downward. So also these angles here, they are equal. Angles in the same segment. So you have to understand, when you look at a diagram, for instance, you're given this is 45. Then they ask you, what is this angle? Look at where they're coming from. These are two angles in the same segment. When you look at where these two angles are coming from, they're coming from the same arc here. You've got this, if you want, we can call these arms. These two arms, they'll meet on the circumference and they are forming what? 45 degrees. If you come back to the same one and go this other way, this is also definitely going to be what? 45. It can also be an angle somewhere here. It can be an angle here, which is here. It's also still 45. We are looking at where they are starting from. Okay? We are looking at where they are starting from. So, angles in the same segment. This is one of the crucial theorems that you have to know, because it's applicable in most of the questions that were given in the exam. Okay? Not forgetting the semicircle one, where we said that an angle in the semicircle is what? So please, let's get to understand this one. If we have something like this, we have an angle here, another angle here. Okay. So if we are coming from this side, we call this is x. This is an arc that we are using here. If this is x, look, we started from this point, we went up to the circumference there, we got x. Also, when you get from this point, this is also going to still be x. It can be an angle, like I was explaining, that will be formed right here. This will still be, these are angles in the same segment. this is the same segment that we are referring to here. So as long as they are starting from the same points here, which give us which we're calling an arc, these three angles are what? They are equal. Okay? So that is the concept that I'm explaining here. If you have got such a case, like you're starting from this point, all these are equal. So I hope you have gotten the concept that I'm trying to explain. You can replay the video over and over until you get the concept. Okay? Let me also just talk about something before I come to these examples. If I have a circle here, then I have got this part. I also have another one here. And we connect this one. Also connect this other one. Then I also do this as well as this one. I say this is A, this is B. So, which angle is equal to this A? Which angle is equal to A according to this theorem that we are applying here? Angles in the same segment. Which angle is equals to A? So you look at where A is. This is our A, isn't it? So let's, like I already said, let's call these two lines arms. So if you want, you can follow these two arms to see where they're coming from. Where they're coming from, it's this point and this one. Do we have other two lines that start from these 2 points and they also meet somewhere on the circumference? The answer is yes. If you look at this line, this one as well as this one, they form an angle on the circumference. So if this angle is A, even this one is what? It's A. Are we together? So if this is given as 60 degrees, even this one will definitely be what? 60 degrees. So when you look at B, where is B coming from? B is coming from this point. So this is our arc. B is coming here. Again, when we come from this point, this is going to be the same as B. This is going to be definitely the same as B because they're coming from the same arc. These are angles in the same segment. If we are using this one, X, look at where it came from. This point and this point. Which one? This one. Okay? This one here. It will also be X. This one, this, where is it coming from? Look, it will be equal to this part here. This one. Equal to this one. So these are the points that you're supposed to know. Angles in the same segment. Angles in the same segment. Just that. So we can look at these examples. Even on, as I was explaining here, I did give you a lot of examples. Okay? So, this, just by virtue of this O, then we know that AC is a diameter. AC is a diameter. That's what it means. This one passes through the center of a circle. So if this is a diameter, okay, I want you to get me. If this is a diameter, or maybe before I come to that, which other angle is equal? Because we have 35. So which other angle is equal to 35? Which other angle is equal to 35? This is like what I advise. It's better you pause the video, try to find the answers even before we go through together. Which other angle is equal to 35? So you're looking at where 35 is coming from. The arc, it's this point, isn't it? So again, if you get this pair of lines, this angle here is also 35. Why? These are angles in the same segment. These are angles in what? In the same segment. You get what I'm saying? Now, because the second theorem that we looked at, we said angle in the semicircle is 90 degrees. The angle in the semicircle is 90 degrees. Then here, we have the angle in this. This is the diameter. The angle that divides the circle into two. So what we have this side, this one, this whole angle here, this angle here, it's what? Supposed to be 90 degrees. Are we together? So to find the value of x, or the x degrees, we are going to say x is equals to 90 degrees minus 35 degrees. Because when we add x and 35, we are supposed to get 90 degrees, because we said an angle in the semicircle is what? It's 90 degrees, or right angle. So what do we get here? What do we get here? X is equals to 10 minus 5, 5. Are we together? Then we have 8 minus 3, it's 5. As simple as that. That is what we are supposed to do. So you see, the first thing, you see how these theorems do apply. We have used this one to get this angle. We used 35 to get this angle. Then when we get to this point, we need to switch to another theorem. So that is why we need to know, even the first one. The first one, we have to know it because at some point it can apply. Okay? So we come to the second one. We need to find this angle that is labeled X here. We want to find the angle ACB. Angle ACB, which is equal to X. What is this angle? Now, the same thing that I'm telling you that when you look at this one, this is a diameter. This is a diameter. So meaning, if this is a diameter, do we have an angle in the semicircle? Yes. It means this angle here is 90 degrees. This angle is 90 degrees. So then, if this angle is 90 degrees, we can easily find this one. Because one thing that we know is that this angle and this one, they are equal. Why? They are angles in the same segment. So we need to find this one so that we make a conclusion that this and this one are equal because they are angles in the same segment. So if this is 90, we also know, like I was saying, that these two, they should add up to what? 90. So this is going to be 25. Am I right? This is going to be 25. Then we know now that X is equals to 25 degrees. If you want, you can say angles in the same segment. Angles in the same segment. This one, once we have found this one, otherwise you can't go straight out to look at. You need to use the information that is given to get to this one. Okay? We need to use the information that is given to get to this one. So basically, this is what we are supposed to do. Alright? I hope you have gotten the concept. So remember that this channel is meant to give mathematics for people that are preparing for their grade 9 exam as well as 12. All the lessons from grade 10 up to 12 have been provided. So make sure you subscribe to this channel. Give us the comments on how best you think we can provide a service to you, our audience. Alright, so let me give you an exercise as our culture. Thank you. Okay, so let's find these angles. Those angles labeled there. Okay. For the second one, I'm sure you can clearly see that that is the diameter there. Okay. It's the diameter there. Okay, so we are finding those angles labeled with letters. Okay. You're using these same theorems that we were. Okay, all these here. All these ones here. Look, I'm giving you as many as possible just for your practice. It's not everything that you have to submit. No. Okay. All these. Okay, so here you're looking at question 9, question 10, question 11. Question 11, you're finding the value of the A. What is the value of A here? Even here, what is the value of X? So you know what this means. These are diameters. So you need to add like here, A plus 2A is equals to what? 90. This one, I think this one you have to think about angles on a straight line. Then you also bring in the other concept that we looked at the other time, which is theorem 1. You need to think about it here because G and E are the same. So you need to think of that. Okay, so I think basically these are... Okay, even this one here, find this angle A. Okay. If you may want even these ones here, find those simple, those angles. The A here, find the A, small letter A. This angle is what we want. Okay. Okay, so if you have any of these books, please refer to them. Thank you so much.